As soon as our systems are anything more than trivial, we need to think about how we're going to organize our code. Let's talk about that to lay the groundwork for building more interesting systems. When software engineers talk about design, we aren't talking about what the system looks like to the user. Think about architects who designed the Freedom Tower. Sure, they were concerned with what the building looked like and how the people would use the building. We worry about those things for software too. But in addition, they had to think about things like, how big a chase do you need in the walls of the first floor to be able to run enough power lines to have power in the 100th floor? So there is an internal type of design that is invisible to the people who use the building, but is critical to the functionality the building provides. In software engineering, we have the same kinds of issues. Of course, we're concerned with what the software looks like to the user. But when we talk about design, we're talking about the internal structure of the software. So for us, designing software means figuring out what the parts of the software should be. For each part, we need to know what information it holds and what things it can do, and how the parts interact with each other to provide the functionality that we need. To understand why we care about design, we have to think about what happens when systems get really big. And when we mean really big, I mean really, really big. It's estimated that the Office suite has 30 million lines of code. When systems are that big, we need things to be well organized to keep track of everything. When we're preparing to build a big system, having a well-organized design helps us understand what we're about to build and gives us some confidence that it'll work. Since the system is big, it's going to take a team of engineers to build it. The design gives us a common language to describe what we are doing, and that helps us distribute the workload across the team and lets us track our progress as we build the system. Finally, once the system is built, a well-structured design helps us find the code that we need to modify, to add new features, and to fix any bugs the system might have. When we design, we think about objects, which are the things the system manages or uses to accomplish its goals.
For example, if we're building an information system for a university, the objects could be students, faculty, and courses. If we're building a game, the objects might be aliens, potions, and weapons. If we're building a system for a bank, the objects might be checking accounts and customers.
And when we design, we aren't thinking about specific objects. Instead, we think about the different types of objects.
So we don't think about a specific student. We think about students in general. We don't think about a specific alien. We think about aliens in general. And we don't think about a specific bank account. We think about bank accounts in general.
When we think about the general groups of objects, we think about two things. First, each object has things it needs to know.
Students need to know their names, their addresses, the courses they took. Aliens need to know what weapons they hold, how fast they can move, and how healthy they are. And bank accounts need to know which customer they're holding money for, what transactions have occurred, and what their balance is.
Right. So every object has variables that hold the things that object needs to know. We call these variables instance variables.
The words object and instance are synonyms. Both mean a thing the system manages or uses to accomplish its goals. Unfortunately, we use them interchangeably.
When we are thinking about objects, the second thing we think about are what things those objects need to be able to do.
Students need to be able to calculate their GPA. Aliens need to be able to shoot their weapons. And bank accounts need to accrue interest.
And we code those actions in methods. These general groups of objects, student, alien, bank account, are called classes. Unfortunately, as a discipline, sometimes we're not careful about how we use words, and in this case, we use the word class for three different things. First, class can mean the Java code that is a template for building objects of a particular group. That's how the structure of our code matches the structure of our design. There will be one source file for each general group of objects, so that source file is called a class. The second way we use the word class is as a non-primitive type we are creating. We've learned about primitive types like int and double. When we're doing object-oriented development, we will be creating new types that are our general groups of objects.
So we'd create new types for student, alien, or account.
Once we create the type, we can declare variables to be of that type. Each of those variables will have an object that is a specific instance of that type.
So when the system is running, there could be a variable holding a student named John, a variable holding an alien with a ray gun, or a variable holding one of John's savings accounts.
The third way we use the word class is to refer to the set of objects of the same type. This underscores the relationship between objects and classes. Specific objects belong to the general class that is their type. Let's look at how those uses of the word class relate to each other. An object is a specific thing. There is a Java file that is a template for a group of objects that specifies what that object knows and what it can do. That object's class is a non-primitive type that we've defined, and that means that it belongs to the class that is the set of things of that type.
Here's an example to clarify. An object is a specific thing, a student named John. There is a student.java file that is a template for student objects that specifies what that object needs to know, like the fact that his name is John, and what it can do, like calculate his GPA. That object's class is a non-primitive type, student, that we defined, and that means that John belongs to the class that is the set of things that are students.
In this video, we learned about object-oriented design because Java is an object-oriented language. The center of how we design are objects, which are the things the system needs to manage or use to accomplish its task. With this strategy, our code will be in classes, which are templates for those objects. We will code what they need to know in instance variables and what they need to do in methods.